Hello, Jimmy Kukulski here, Elite Lubrication Specialties, another 2-minute Tribo tip. All right, so I get a lot of customers that buy performance oils, and one thing they're always telling me is, I can lower my viscosity, or I can go with this low 530 or 020 or 016 or whatever it is, because in my engine, when we did dyno testing, when we lowered the viscosity, we gained horsepower. Well, that's true. When you lower viscosity, you have less fluid friction, and less fluid friction translates into less generating heat, etc., which means more horsepower. However, there's a difference between what a lot of these engine oil manufacturers are talking about, which is called shear stability, and viscosity. Viscosity is required at a certain temperature for a certain load for a certain speed, right? So opposing bearing surface velocity, rotational speed on rolling elements, gear sets, etc., etc. So that speed determines your viscosity. That load determines your viscosity, not shear stability. All right? And there's a difference between shear stability and viscosity. Right here, I have a shear stable and an unshear stable element. I've got this, which is gelatin, and this, which is a taffy. Now, these two products are very similar in viscosity. If I tried to measure their viscosity, they'd probably be very similar because they obviously aren't going to flow anywhere very fast. If anything, this is actually less viscous than this. But what happens when you put them under a load? So if you have the same viscosity, the Jello, I can push right through it. It's has a very low shear stability, okay? Same viscosity, low shear stability. It shears very easily, even though it has a high vis. Taffy, on the other hand, even though it may be a little bit less viscous, or the same viscosity as the Jello, has a very high shear stability. You can put a lot of load, it's not losing its viscosity, it's not breaking up, it's not separating from itself. Same viscosity, different shear stability. Now what that means is you have a little bit of a buffer zone, right? You could use a little bit of less viscosity at the same load and the same speed if you have a higher shear stability. And you'll notice that OEMs are going lower and lower and lower. I think Honda's now at 0W16. I see a lot of 0W20s out there. We're going to see a lot of lower vis. And the reason why people are going to lower viscosity isn't necessarily just tolerances. A lot of people are getting confused between tolerances and the actual reason we choose viscosity. Viscosity is chosen on opposing surface velocity, or speed, and load. Tolerances are to keep that viscosity in check. There's only so tight you can go on tolerances before you actually have to turn into an F1 race car where you heat every single piece of metal and the oil and the lubricant up to a certain temperature before you can actually start it, right? So we can only go so tight on tolerances, but we can decrease viscosity and increase shear stability, but that's only so far. We're not talking about race engines. I was at a sponsored race that I do a couple of years back, and a guy came up and said, yeah, I'm using 5W30 in my 800 horsepower car, and we gained 15 horse by changing the oil to that. Well, yeah, of course you did. You lowered your fluid friction, but you're going to start to lose some of your film strength. Even though it has higher shear stability, you still need the flow through the bearing to be slower, to be able to keep those two parts separate. If this flows fast, really fast out of the way, then the bearing surface and the journal can touch each other a lot faster under a higher load or a lower speed. So keep that in mind. Shear stability is important, but it's not everything. Viscosity is the #1 thing you have to watch for at your operating temperature, at your speed, and at your load. Thanks.